We're going to solve quadratic systems. And I put in here substitution and linear combinations because what you have done in the past is that you've had two lines. And you found whether or not the two lines would intersect. You did that via linear combinations or substitutions. Vaguely remember that?
Yes.
Okay. Well, like I said yesterday, instead of working with lines, we're going to be finding the intersection of a line and a circle. So how many places can a line and a circle possibly intersect? Two, one, or none. You agree?
Yes.
Same idea with two circles. Two circles can intersect at two spots, one spot, or they could wind up being the exact same circle. Do you agree?
Yes.
So what if the large circle had a diameter of 6 and the small circle had a diameter of 2?
There have to be concentric circles.
Oh yeah. Oh yeah. Like what's it called? The difference between the center for both circles was 5. 5.
I think it's 2.
Oh, is this a question you guys just did?
No, I
where do you
just
got
happened
it?
to ask it.
Wait, what was the question?
Okay, so the small one has a diameter of 2. The big
Diameter
one
of
has
2.
a diameter of 6. And how many times, or if at all, do the circles intersect?
Distance from the center is 5.
Yeah, this is the center is 5. So is the small one inside it? Do they intersect like once or twice, or are they like not even touching?
Wait. So if the diameter is 2, that means the radius of the small circle is 1. The radius of the large circle is 3. And you're saying
The radius of the large circle is 6.
oh, at least the diameter was 6.
No,
Okay.
What?
it was the radius.
For both of them?
I don't know.
I don't know, but
I thought it was
maybe
diameter. I think it's diameter.
I think you guys are agreeing yourself.
I'll think of, let me figure that out later. Let me do this first.
Okay.
So speaking of circles, nice segue there. You're not having to graph any of this stuff, just so you guys know. What we're doing here is we're working algebraically. We're going to find the intersection, the possible intersection points of two figures, or more. So in this case here, we have two equations. We have the equation of the circle, which is x squared plus y squared equals 13. And I have the equation y equals x plus 1, which tells me it's a line. You agree? Now, just a second ago, we had talked about the possible ways a line and a circle could intersect. A line and a circle could intersect at 2 spots, 1 spot, or no spots. Do you agree?
Yes.
All right. So what we're going to try to do is see what are the possible ones that we could get from these two. So this is where all that substitution, linear combination stuff comes back into play. Now, if I'm looking at this here, do I have one of the equations already solved for one variable?
Yeah, you get why.
I have y. So that means I can substitute in y here.
Oh, that's crazy.
X squared plus quantity x plus 1 squared equals 13. Don't kill a puppy.
I totally agree.
I killed puppies.
Yeah, foil it.
Oh, that's.
So you wind up with x squared plus x squared plus 2x plus 1 equals 13. Which turns this into a very simple factoring problem. Combine your like terms and move that 13 over, and you wind up with 2x squared plus 2x minus 12 is 0. Is everybody okay with that?
Yes.
Now, what's your first rule of factoring?
GCF.
GCF. What's my GCF here, guys? 2. So if I factor out a 2, I'm left with x squared plus x minus 6 equals 0. Are we okay with that?
Yes. Yes, sir.
Now, what can I do with that 2 since it is a constant?
Divide.
If I divide out by 2, does it go away?
Yes. Yeah, it does.
Okay. Now, what times what is negative 6? When I add together, I get positive 1.
Negative 6.
2 positive 3.
Negative 2, positive 3.
Sorry, I was thinking 5.
My terms, remember, the terms are what are in parentheses. The zeros are the answers. So my terms are x plus 3, x minus 2. My zeros, therefore, are negative 3 and positive 2. So that means the intersection of this line and that circle has 2 possible x values, which means it's going to intersect it twice. So here's what we do. Since we have 2 x values, we're going to have 2 sets of ordered pairs. One of the ordered pairs will have an x value of negative 3. The other one will have an x value of 2. What do you do to figure out the y values? You substitute.
Ah!
Didn't we have this earlier where it was y was equal to x plus 1?
So y minus 1 equals x. When negative 3 is equal to x.
Why not even do this? What's negative 3 plus 1?
Negative 2.
What's 2 plus 1? You were making it tougher than you need to. And you're done.
Oh, it's like the opposite. Holy crap. No, it's going to be like that.
No.
Like,
Is it ever always?
Not necessarily. No. No, it's not so much, it's not so much more, it's not that's going to be that more complicated. It's just remembering how to set these things through, okay? Okay?
Just have to get used to it.
Okay, same idea. Remember, when we're setting these types of things together, there are multiple ways of setting them up. Now I have x squared plus 4y squared minus 4 equals 0, and negative 2y squared plus x plus 2 equals 0. So for 1 million bonus points, that's funny, what are these two shapes?
Circles.
Wrong.
Ellipse.
And?
Lines. Circle. Ellipse in a circle. And a trapezoid.
Yeah.
There's 4 of them.
What was that?
Parabola.
Parabola. This is the intersection of an ellipse and a parabola.
I was half right and she was half right, so can we each get like 500,000?
So x squared, 4y squared
No.
makes the ellipse, and then the negative 2y squared makes the...
Now, hey guys, is it the end of the world? Is it the end of the world that you didn't know that off the top of your head? Yes. But am I going to yell at you? This top one, I know that it's going to be an ellipse because it's x squared plus 4y squared. If I move that over, I get a 4. If I divide it out, I'll have an a squared and a b squared.
And since it's not equal.
I knew
Since
that.
it's not equal, it's an ellipse. Yes, ma'am.
So,
Should we solve it?
So basically, there's a coefficient.
on the test, will you like tell us that it's the intersection of an ellipse and the circle?
Do you even need to know?
Yes.
No.
No, because we're not graphing.
Because we're not graphing them, so you really don't need to know. It really has no bearing upon the problem, unless you want to visualize what the heck is going on.
I don't want to.
Yes, ma'am.
Can I get that same one sheet got last time?
Yes.
Turn up.
Now, in this case here, there's a little trick going on. What I want you to notice is that you've got x squared, y squared in the first one, a y squared in the second, but a single value of x. Everybody see that?
Yes.
So what I want to do is take that second value. I'm going to set it equal to x. I'm going to x by itself. Okay?
It's 2y squared minus 2.
Yes. I'm going to get x squared by, or x by itself. So I get x will equal 2y squared
Minus 2.
minus 2. Are we okay with that?
Yes.
Okay. So excited, he's falling out of his chair.
He just like stood up.
Once again, I'm going to use substitution here. And I'm going to get 2y squared minus 2, quantity squared, plus 4y squared minus 4 is 0. Okay. You just FOIL it, yeah. You FOIL it out again. Okay?
Holy.
Yes? When you FOIL this out, you get 4y to the fourth minus 4y squared minus 4y squared plus 4. Yes, ma'am?
Okay, I always get confused with this. Are you adding a 2 or multiplying a 2 with those exponents? I can never
You
remember.
add.
You add, okay, thank you.
Okay.
I was-
And now I have tack on the rest. Plus 4y squared minus 4 is 0.
Just a few forwards.
Just a few of them, yes. Well, you should be happy, at least one of them drops out. Or 2 of them, I should say. So what I'm going to do here is combine like terms, and hopefully you guys see what's going on here. One of these goes with this one goes away with that. And all I'm left with is 4y to the fourth minus 4y squared is 0. And I'm back to a plain old boring factoring problem. What's your first rule of factoring? GCF. Nope.
Squared.
Because you can't do that. You can't do that over addition. Or subtraction.
How do you read that?
You can't do that. It's not dumb. What's your first rule of...
Can't you?
She went to take the square root. You can't do that.
Oh.
Factor out your 4y squared, and you're left with y squared minus 1.
Oh, because you got
Because that's your GCI.
That's your first rule of factoring, guys. It hasn't changed.
Sorry, I was thinking, yeah, but we just took out.
Do we now have 2 terms?
Okay.
Factor out include 0.
So y squared minus 1.
So I have 4y squared equals 0. What's y here?
Oh, I see what you're doing.
So y is 0.
Oh, and then y is square root of 1.
Isn't this a difference of squares? Is y squared a perfect square?
Yes.
Is 1 a perfect square?
Yes.
Is that a subtraction sign?
Yes.
Isn't that y minus 1, y plus 1?
Yeah, so it's, okay.
So your other zeros are at 1 and negative 1? So you have 3 possible y coordinates, which means how many possible x coordinates are you going to have? 3 of them. Yes, ma'am. Where?
Wait, how'd you get?
Let's solve y.
How'd you go? 0 divided by 4 is 0, then the square root is 0.
Divide anything. Well, divide 0 by anything.
So you have 3 possible ordered pairs. Guys, it's just a factoring problem that you guys have all done. You have 3 possible values for y. How are you going to figure out your 3 possible values for x?
You're gonna do
You
a
substitute back in. If I go way back up top here again, didn't I have x equal to 2y squared minus 2?
Yes.
Yes, you can divide that.
So x is equal to 2y squared minus 2. What's 0 squared? What's 0 times 2? What's 0 minus 2?
negative 2.
What's 1 squared?
1.
What's 1 times 2? 2. What's 2 minus 2?
0.
What's negative 1 squared?
1.
What's 1 times 2?
2.
What's 2 minus 2?
0.
What's your answers?
So there's x 3 times.
Hey, there's no bad.
All we're doing is substitute back in. Yeah, basically if you really wanted to know what this looked like I said, this is an ellipse and a parabola. And it's doing something, well, oops. It's touching at 3,
Oh, so it's not
Really is not your side.
no. So if you have an ellipse and a parabola, you can do it easier this way. When you get the idea, it's kind of tough. Yeah, I'm trying to get this to blend right. I don't know. You get
Just make the lips a little bit. Okay, now that'll be good.
there. There you go. There's 3 spots. But sooner or later I figure it out. What's up? Try that one.
So if it was like, y squared.
When it's starting like half of first school.
No, it'd be plus or minus 3. It was y squared minus 9, it's y plus 3y minus 3. That's what it is. Okay. Now, take a look at this one. This one should look a little bit easier to you. No. You can't just take square roots, guys. It doesn't work. You cannot do that. Don't do that. You're going to be automatically wrong. You can subtract or equal. I'd rather add, because you have less of a likelihood of screwing your signs.
Okay. Yeah.
Now, if you look up on the board here, if you look at the board, you'll notice that I wrote some general rules from way back when about linear combinations. If you had the same sign with the same coefficient before, you would subtract. If you had the different sign with the same coefficient, you would add. What I did there was I added the following statement. Same sign, same coefficient, same exponent. So I want to be in the same degree. Then I would subtract. Different sign, same coefficient, same exponent. I would add them together. The benefit of adding versus subtracting is that you don't necessarily run into problems with all of your signs. So if I notice that I've got, in this case, see how we have x squared and x squared, top and bottom? We have y squared and a negative y squared, top to bottom. But then I have an x and nothing. Which means, am I going to try and get rid of the x? Ladies, stop. In this case here, am I going to try and get rid of the x squareds or the y squareds? I want to get rid of the y squareds because that way I can solve a quadratic if I need to with the x squared and the x. And the way that I can eliminate them is by doing what? Add them together. Very good. So what I'm going to do is I'm going to kind of rewrite this real quick so that I line up my x squareds and y squareds and all those terms together just to make it look a little bit cleaner. So I'm just going to rewrite this real fast. So we had x squared minus y squared. It was minus 9, correct?
Yeah.
Yes.
All I did was just rewrite them so they lined up underneath one another. And I'm going to add these two equations together. This is my linear combination. X squared plus x squared is 2x squared. Y squared minus y squared is gone. Minus 16x. What's 39 minus 9?
30.
And back to, what's your first rule? Backward. What's my GCF, ladies and gentlemen? 2. Do I have to worry about that 2 anymore? Why did I have to worry about that 4y squared last time? Because it had a variable. Very good. Okay. This doesn't have a variable, so it really has no bearing upon the problem. So what times what's 15? You add together to get negative 8.
Negative 3, negative 5.
Very good. Negative 3, negative 5. So my terms are x minus 3, x minus 5, which gives me solution zeros at 5 and 3. Very good. Excuse me. Now, it's possibly intersecting twice. It could be more. We don't know yet. There are 2 possible x values. The 2 possible x values we have as of right now are at 3 and 5. Now, when I go back to the original problem, does it matter which of the 2 I substituted for x? No, but do you see how it might be easier with that secondary equation? You see how that would work? If I substitute with that secondary equation, I get x squared minus 9 is y squared. We okay with that? by moving that around? I'm looking at using the second equation. Now, if I'm going to solve for y, now what can I do to both sides of the equation? Take the square root. So, finally, yes. When I take the square root over an equal sign, what do I have to put out there? Plus or minus. So I wind up with positive minus square root of x squared minus 9 will give me y. Notice I did not take the square root of x squared minus 9 and write x minus 3. That would be wrong. I'm taking the whole thing. All right? So substitute in for x. What's 3 squared? What's 3 squared minus 9? What's the square root of 0? So when x is 3, y is? Okay. I do the same thing for 5. What's 5 squared?
25.
What's 25 minus 9?
16.
What's the square root of 16?
4.
Plus or minus 4. So in this case, 5 is at both positive 4 and negative 4.
Oh, so it's 3.
It's 3 solutions here. It has a minimal possibilities of 2 solutions because there's 2 x values, but in fact there are 3 y values that happen.
That's real funky.
It is real funky.
Wait, why is it?
Notice how I have 2 y values plus minus 4? What I'm doing here is instead of rewriting this as 5 minus 4 and 5, that's all it was. That's all that meant. Okay. If you want to write them as separate entities, that's fine. Okay. It works just the same. All right. Now, as you get into these things, yeah, you're going to get some of these duplicate solutions. Be very careful when you start doing square roots. Okay. These aren't the easiest things to check graphically to see if you will have 1, 2, 3, 4 possible solutions. Because I don't know about you, but I'd have to complete the square here to wind up with some funky ellipse, and the second one is going to be a hyperbola. So I'm looking at the intersection of a weird ellipse and a hyperbola. That's a lot of work to have to graph out to get actual ordered pairs. I don't want to do that. I know.
I'm what the book does.
Yes, sir. No.
Wouldn't the bottom one be a circle because they're both over 9?
What's between them, though? That's why. What happens in this case is that you know how we made those rectangular boxes?
Yeah.
It's a square. So you have a slope of 1 for your slant asymptotes. That's what happens in this case. Okay. Preguntas para su clase de matemáticas?
Oh, now you're gonna say three.
No preguntas. Tarea ahora aquí?
No.
Sí.
Maybe 7 of them. I think the first 4 of them should be relatively easy.
Is there any way we can take John? Wait, tomorrow?
Yeah.
Because tomorrow's just a review day.
Well, don't you want that review?
Yeah.
I don't want to take it tomorrow.
Well, yeah, we're taking it Monday.
I need the weekend to study.
You're not going to take it.